All right, before we continue with our right triangle trig chapter, I want to take a second to give you a little brief introduction into radical expressions. Now, one thing's important about radical expressions is knowing what perfect squares are. I have a list of perfect squares here. There are many, many more, but I think this is probably all we need to know. And you don't really have to memorize a lot of these, but you have to recognize these as special numbers. A perfect square is what you get when a number is multiplied to itself. So 1 is 1 times 1. 4 is 2 times 2. 36 is 6 times 6. 9 is 9 times 9, and so forth, up to 15 times 15. Okay, so the square root of 49, we would just say 7. Square root of 81 would be 9. Square root of 16 would turn into 4. And these are whole numbers, okay? A whole number 9, a whole number 7, and a whole number 4. So when you get a problem like this is really 3 times, we say this is 3 times radical 4 or 3 radical 4, not 3 square root 4. 3 radical 4. And we need to know how to simplify this, because 4, anytime you see a 4 underneath the radical, that needs to be reduced, because this is where we can reduce it further. So this is really 3 times the square root of 4. And the square root of 4 is the whole number 2. So this really becomes 3 times 2, and the final answer is 6. So this is really 5 times the square root of 9. 5 radical 9 cannot stay 5 radical 9. We have to reduce it. Now this is really 5 times the square root of 9 is a whole number 3. 5 times 3 becomes 15. So what we're looking for is multiplying what are alike. So whole numbers are alike. I can say 5 times 3. They're alike, whole number and whole number. 5 times radical 2 are not alike. So how do we multiply 5 times radical 2? Well, it's really kind of like saying 5 times x. 5 times x would be 5x. 5 times radical 2 would be 5 radical 2. So when they're not like terms, we can write them next to each other like this. When they are like terms, like this, we multiply 5 times 3 and 3 times 2. So let's show you a couple problems. See, what's nice about the ones we're going to do in this chapter, they are very small radicals. So radical 3 times radical 3 are alike. So I can multiply them. So they become radical 9. And radical 9 from the top of our page is a square root. 9 is a square root. So I have to keep going to simplify this. The square root of 9 becomes a whole number 3. Not radical 3, but a whole number 3. And that is the final answer. We're reducing them. Radical 2 times radical 3 is radical 6. Now radical 6 cannot be broken down. If you were to put this in your calculator, you would get a decimal. And you cannot have any decimals in the answers that you give me in this chapter. Or at least when we're working with our right triangles. When we get to trig, that's the second half of this chapter. You can give me decimals. But before we get to trig, in this section coming up next called special right triangles, everything will be a radical. So the radical 6 cannot be broken down. The only radical that goes into it is 4, and 4 does not go into 6 through multiplication. So actually, the square root of 6 is its final answer. We cannot reduce that any further. Let's go to radical 2 times radical 2. That's a radical 4, and that is one of our special numbers. So the square root of 4, if you put that in your calculator, you do get an answer that's not a decimal, and it's a whole number 2. A whole number. And that is the final answer. The answer reduced is 2. All right, so let me show you some multiplication when we have coefficients. That's something in front of a variable or a radical, like 5x. So we have a whole number, we have a radical, and I put them in different colors. See, the radicals are like terms. Those are what I can multiply. The whole number, I do not multiply it. So it still stays 5, and then it's radical 6. Now, we already talked about radical 6 being a special number we can't break down. So your answer to reduce this all the way and not have any decimals is 5 radical 6. Okay, once again, on 11 radical 3 times radical 3, we have a whole number and 2 things that are alike. So I'm multiplying the 2 things that are alike. 9 is one of our special numbers. The square root of 9 is 3. So this really becomes 11 times 3. And your final answer is 33. On this problem, we have 2 whole numbers I'll identify in red, and 2 radicals I'll identify as in blue. So I'm going to multiply everything that's alike. The 2 reds are the 2 whole numbers. I'll multiply them. The 2 radicals, 2 times 2 is radical 4. Radical 4 is on our list. The square root of 4 is a whole number. So I need to continue to reduce this. The square root of 4 is 2. And 6 times 2, our final answer is 12. Remember, you can rewind and pause if you need to, but I'm going to go so I make this video not too long. Dividing. So basically a fraction. So if we have a whole number of 3 on top of 3, 3 divided by 3 becomes 1. If we have an x on top of x, they cancel out, but we still have to make it 1. And that's true on these. So radical 3 and radical 3 will cancel out, but I still have to make this answer a 1. Anything divided by itself is 1. Okay, so this one I have 12 divided by 3 under the radical. So I'm kind of ignoring the radical until the end. So I can say 12 divided by 3 is 4. And I'll keep the radical there. And that's one of our special numbers. 12, or the square root of 4 is 2. And we're done. You get in a situation like this, 5 radical 2 over radical 2. These are alike and we can cancel them out. So your final answer here would just be 5. If you like to keep this over 1, you can. Or a 2 over 1, you can. All right. So I can't do anything with the 4. I'll rewrite it. 15 divided by 3 would be 5, and I'll show you that it's on top of a fraction. And I cannot do anything with this. Nothing that's a perfect square multiplies into 5. And if I take radical 5 in my calculator, I'll get a decimal. So I cannot reduce this any further, and that would be your final answer. So now, finally, I'm getting to the tough stuff. This is how radicals work, and it's going to be strange, but we're just going to continuously do it And eventually, you're just going to catch on that it's just another rule in math. When I divide by a radical 2, so 10 divided by radical 2. First off, read what I have here in big print. You cannot have a radical on a denominator. A denominator is on the bottom of a fraction bar. So how would I get rid of this? Well, the sneaky thing about math is if you multiply anything by 1, you're not hurting anything. For instance, 10 times 1 is just 10. Okay? 3/4 times 1 is simply 3/4. But you have to remember, the sneaky thing about what I'm about to show you here is there's an infinite amount of ways I can show you what 1 looks like. How can I identify 1? Well, here's one way to identify 1. 5/5. Another way would be x/x. X divided by x is 1. 3 radical 3 over 3 radical 3 would also be 1. So how do we get a radical off the denominator? Is the rule is we're going to times it by 1. And how do I multiply 10 divided by radical 2 by 1? Is you are going to identify your radical that's on the bottom, and you're going to multiply it by 1 with that radical. I'm picking radical 2 because that's what's on the bottom. I'm multiplying it by 1. This is multiplying it by 1. Radical 2 over radical 2 really is 1. Now watch what happens. The tops you'll multiply. Here's the outcome. 10 times radical 2 is 10 radical 2. Radical 2 times radical 2 is radical 4. Now look what happens. Radical 4 is a special number. That can be taken care of. The square root of 4 is 2. Now look, the radical on the bottom is gone. And now all I do is have to reduce. This is a radical 2. There's no other radical. The radical 2 stays on top. 10 divided by 2 is 5. Your answer is 5 radical 2, and it would be over 1, but that's not necessary. So it'd be 5 radical 2. One more time. This is 4 divided by radical 5. I'm going to multiply by 1 to get rid of that radical 5. And what does it need to look like? Radical 5 over radical 5. There's another. That does come out to be 1. 4 times radical 5 is on the top. That's 4 radical 5. And radical 5 times radical 5 is a special number. It's in our list. The square root of 25 is a whole number. The square root of 25 is 5. So now look at what we have. So let's see if I can reduce this. Radical 5, can't do anything with it. 4 over 5 can't be reduced. Now guess what? Since I can't reduce or cancel anything else out, and there's no radical on the denominator, that answer is done. Okay, I'm going to do it again. There's a radical 2 on the bottom. I don't want that. So really, I'm just going to steal this. I'm going to multiply it by my 1 here. Whatever the radical is, I'm just putting that on top of itself to make it into 1. So 13 times radical 2 is 13 radical 2. Radical 2 times radical 2 is radical 4. Radical 4 is one of our special numbers. 13 radical 2 isn't touched yet. This becomes 2. Now, radical 2 can't be reduced because it's a decimal. 13 divided by 2 is a decimal. And 13 over 2 can't be reduced. That is our answer. Look at this problem. We only multiply by 1 if there's a radical in the denominator. This radical is on the numerator. That's allowed. So this is actually a trick question. I don't have to multiply this by 1 because I don't need to eliminate a radical on the bottom. So let's see. Radical 3 is not a special number. That turns into a decimal, and I can't have that. 9 over 2 can't reduce. And 9 divided by 2 is a decimal. So, believe it or not, this cannot be reduced because we have to avoid a decimal. So, this is actually the final answer. You can't do anything with it that would, not produce a decimal. And there is our little intro into radical expressions. I hope I made sense of all that. And remember, you can watch this video as many times as you need to and rewind it.